Discovering the oldest rocks on Earth, a Canadian marvel. Uncovering Earth's oldest rocks, 4 billion years of history revealed. Exploring the oldest rocks on Earth, the Nuvvuagittuq Formation. World's oldest rocks, a journey into Earth's Hadean. Unearthing Earth's oldest crust, 4.2 billion-year-old rocks in Canada. Discovering the oldest rocks on Earth, a Canadian marvel. Unveiling the ancient secrets of the Earth, Canada's oldest rocks. Imagine holding a piece of the Earth's history in your hands, a relic that dates back to a time when our planet was still in its formative stages. Scientists have made a groundbreaking discovery in Canada, uncovering what could be the oldest rocks on Earth, offering a glimpse into the Earth's mysterious past. In a remarkable find, researchers have identified a rock formation in Canada that could be the oldest on the planet. This extraordinary discovery has the potential to rewrite the Earth's history books, providing valuable insights into the Earth's formation and evolution. But here's where it gets controversial. The age of these rocks is still a topic of debate among scientists. While some believe they could be as old as 4.5 billion years, others argue that they may be significantly younger. The uncertainty surrounding their age only adds to the intrigue, sparking a heated discussion among geologists and earth scientists. The Nuvvuagittuq Greenstone Belt in Canada is the site of this remarkable discovery. This region is known for its unique geological features, which have been shaped by billions of years of volcanic activity, tectonic plate movement, and weathering. The rocks found in this area are unlike any others, with their distinct composition and structure telling a story of the Earth's ancient past. So, what makes these rocks so special? For starters, they are incredibly old, with some estimates suggesting they could be as old as the Earth itself. This raises questions about the Earth's formation and the processes that shaped our planet. Were these rocks formed during a period of intense volcanic activity, or did they emerge from the Earth's mantle through a process known as plate tectonics? The discovery of these ancient rocks also has significant implications for our understanding of the Earth's history. It challenges our current understanding of the Earth's formation and evolution, forcing us to re-examine our assumptions about the planet's early days. And this is the part most people miss. The significance of this discovery goes beyond the rocks themselves, offering a window into the Earth's mysterious past. As scientists continue to study these ancient rocks, they may uncover secrets that have been hidden for billions of years. The discovery of these rocks is a reminder of the awe-inspiring complexity of the Earth's history and the many mysteries that still remain to be uncovered. Now, it's your turn. Do you think these rocks are truly the oldest on Earth, or is there more to the story? Share your thoughts in the comments below. Uncovering Earth's oldest rocks, 4 billion years of history revealed. Imagine holding a piece of Earth's history in your hands, a rock that has witnessed the birth of our planet. The oldest rocks on our planet are over 4 billion years old, offering a rare glimpse into the distant past. Earth took shape around 4.6 billion years ago during the Hadean, a time named after the Greek god of the underworld, Hades, due to the extreme heat that characterized the planet. This period is shrouded in mystery, as very few rocks and minerals from this era have survived the test of time. The scarcity of preserved geological records makes it challenging to piece together what Earth looked like during the Hadean, leaving many questions about its earliest evolution unanswered. But here's where it gets controversial. The age of these ancient rocks has been a subject of ongoing scientific debate, with some researchers proposing different timelines. Our research team has confirmed that the oldest known rocks on Earth are located in northern Quebec, dating back more than 4 billion years. These rocks provide an invaluable glimpse into the origins of our planet, offering clues about the formation of the first crust and the emergence of life. The Hadean, the first period in the geological timescale, spans from Earth's formation 4.6 billion years ago to around 4.03 billion years ago. The oldest terrestrial materials ever dated by scientists are extremely rare zircon minerals discovered in Western Australia. These zircons, formed as early as 4.4 billion years ago, have given us clues about the Hadean environment and the formation and evolution of Earth's oldest crust. The chemistry of these zircons suggests that they formed in magmas produced by the melting of sediments deposited at the bottom of an ancient ocean, indicating that liquid water oceans were formed early on. Other research suggests that the Earth's earliest crust was mafic, rich in magnesium and iron. Until recently, the existence of that crust remained to be confirmed. In 2008, a study led by Associate Professor Jonathan O'Neill proposed that rocks of this ancient crust had been preserved in northern Quebec and were the only known vestige of the Hadean. The Nuvvuagittuq Greenstone Belt, located in the northernmost region of Quebec, is home to these ancient rocks. The most common rocks in the belt are called the Geological rocks, meaning big old solid rock in Inuktitut. The age of 4.3 billion years was proposed after variations in neodymium-142 were detected, an isotope produced exclusively during the Hadean through the radioactive decay of samarium-146. This interpretation, however, was challenged by several research groups, some of whom studied zircons within the belt and proposed a younger age of at most 3.78 billion years, placing the rocks in the Archean Eon instead. And this is the part most people miss. The controversy surrounding the age of these rocks highlights the challenges and complexities of dating ancient geological formations. In the summer of 2017, our team returned to the Nuvvuagittuq Belt to take a closer look at the ancient rocks. We collected intrusive rocks called metagabros that cut across the Geological rock formation, hoping to obtain independent age constraints. The project was led by master's student Crust at the University of Ottawa, who joined us in the field. Back in the laboratory, we collaborated with French geochronologist Jean-Louis Paquet. Additionally, 2 undergraduate students, David Ben, University of Ottawa, and Joélie Placombe, Carleton University, participated in the project. We combined our field observations with petrology, geochemistry, geochronology, and applied 2 independent samarium-neodymium age dating methods, dating techniques used to assess the absolute ages of magmatic rocks before they became metamorphic rocks. Both assessments yielded the same result. The intrusive rocks are 4.16 billion years old. Since these metagabros cut across the Geological formation, the Geological rocks must be even older, placing them firmly in the Hadean Eon. Studying the Nuvvuagittuq rocks, the only preserved rocks from the Hadean, provides a unique opportunity to learn about the earliest history of our planet. They can help us understand how the first continents formed and how and when Earth's environment evolved to become habitable. So, what do you think? Do you believe these ancient rocks hold the key to understanding the early evolution of our planet, or is there more to the story? Share your thoughts in the comments below. Exploring the oldest rocks on Earth, the Nuvvuagittuq Formation. Unlocking the secrets of the ancient Earth. Imagine being able to gaze back in time to the dawn of our planet's existence. A recent discovery in Quebec's Nunavut region has given scientists a rare glimpse into the early history of Earth, dating back an astonishing 4.3 billion years. This ancient rock formation, known as the Nuvvuagittuq, is not only the oldest on our planet, but also provides a unique window into the Earth's first ion, the Hadean, just a few 100 million years after its formation 4.5 billion years ago. And this is the part most people miss. The implications of this discovery are far-reaching and have the potential to challenge our current understanding of the Earth's history. By studying the Nuvvuagittuq, scientists can gain insights into the Earth's early atmosphere, the formation of the oceans, and the emergence of life itself. This is a game-changer for the scientific community, offering a chance to rewrite the textbooks and refine our understanding of the Earth's early years. World's oldest rocks, a journey into Earth's Hadean Eon. Imagine holding a piece of Earth's history in your hands, a fragment of the planet's crust that's a staggering 4 billion years old. This is exactly what scientists have discovered in a remote region of northern Quebec, Canada, where the oldest known rocks on the planet have been unearthed. The Nuvvuagittuq Greenstone Belt, NGB, rock formation has yielded pieces of Earth's crust that date back an astonishing 4.3 billion years, a time when the Earth was still in its formative stages, known as the Hadean Eon. But here's where it gets fascinating. These ancient rocks have been at the center of a heated debate among scientists, with some questioning their age and others convinced of their significance. Geologist Jonathan O'Neill from the University of Ottawa, who first discovered the rocks in 2008, has spent over a decade studying the NV, and his latest research suggests that the rocks are indeed 4.16 billion years old, making them the oldest known rocks on the planet. But what's even more remarkable is that these rocks formed during a time when the Earth was a scorching hot, volcanic landscape, with surface temperatures reaching as high as 230 degrees Celsius, similar to the temperature used to bake pizzas. This period, known as the Hadean Eon, was named after the Greek god of the underworld, Hades, and was characterized by intense volcanic activity and a surface that resembled a ball of molten lava. And this is the part that most people miss. Despite the hostile conditions, the Earth had already begun to form a solid crust, paving the way for the emergence of life. The discovery of these ancient rocks has significant implications for our understanding of the Earth's early history and the conditions that gave rise to life. As O'Neill explained, these rocks and the Nuvvuagittuq Belt being the only rock record from the Hadean, they offer a unique window into our planet's earliest time to better understand how the first crust formed on Earth and what were the geodynamic processes involved. The rocks also provide valuable insights into the composition of the first oceans and the environment in which life could have begun. However, the discovery of these rocks has also sparked controversy, particularly among the local Inuit community, who are concerned about the impact of scientific research on their land. The NV lies within Inuit land near the town of Unearthing, and the community is calling for protections to be put in place to prevent further damage to the area. As Tommy Palliser of the Putuvik Landholding Corporation noted, there's a lot of interest in these rocks, which we understand, but we just don't want any more damage. The community is advocating for the use of non-invasive techniques to study the rocks, rather than removing large chunks of rock, which has been the practice in the past. So, what do you think? Should scientists be allowed to continue studying these ancient rocks, even if it means potentially damaging the surrounding area? Or do you think the concerns of the local community should take precedence? Share your thoughts in the comments below. One thing is certain, however, the discovery of these 4-billion-year-old rocks has opened up a new window into the Earth's early history, and their significance cannot be overstated. As we continue to learn more about these ancient rocks, we may uncover even more secrets about the Earth's formation and the emergence of life, and that's a truly exciting prospect. Unearthing Earth's oldest crust, 4.2-billion-year-old rocks in Canada. Imagine uncovering a piece of Earth's infancy, something that has witnessed the planet's chaotic beginnings and survived billions of years of transformation. Now, imagine this relic isn't hidden in some far-off land, but buried right beneath our feet, deep within Canada's rugged terrain. This is no ordinary discovery. It's a fragment of Earth's original crust, nearly 4.2 billion years old, offering us a rare glimpse into the turbulent birth of our world. But here's where it gets fascinating. For decades, scientists believed that Earth's earliest crust had been entirely erased by relentless asteroid impacts, volcanic activity, and the constant shifting of tectonic plates. These forces reshaped the surface countless times over billions of years, leaving behind only whispers of what once was. Yet, recent findings suggest otherwise. Hidden in northeastern Canada lies an ancient geological treasure trove, the Nuvvuagittuq Greenstone Belt, which may hold the key to understanding Earth's formative years. Earth itself is around 4.5 billion years old, and its early days were anything but calm. Picture a young planet bombarded by asteroids, with molten rock oozing across its surface like rivers of fire. Tectonic plates moved restlessly, colliding and pulling apart, while massive volcanic eruptions spewed magma high into the atmosphere. Over time, erosion wore away much of the evidence of these primordial events, burying any surviving remnants under layers of newer material. Until now, geologists thought the oldest known pieces of Earth's crust dated back to the Archean period, roughly 3.8 billion years ago. However, the Hadean epoch, a time shrouded in mystery, is where the story truly begins. Spanning from about 4.6 to 4 billion years ago, The Hadean represents Earth's fiery adolescence, when the solar system itself was still coalescing out of gas and dust clouds left behind by dying stars. For years, researchers relied on meteorites and lunar samples to piece together this era because no direct evidence from Earth seemed to exist. That is, until a bold claim emerged. In 2008, Canadian geologist Jonathan O'Neill made headlines with a controversial assertion. He and his team had identified a section of Earth's original crust in the remote wilderness of northeastern Canada. The Nuvvuagittuq Greenstone Belt, they argued, contained rocks formed during the Hadean epoch, predating everything else ever discovered on Earth. But not everyone agreed. Skeptics pointed to other studies suggesting the rocks were merely 3.8 billion years old, placing them squarely in the Archean period instead. So how did O'Neill prove his case? The answer lay in isotopic detective work. While earlier research often focused on zircons, tiny crystals prized for their ability to preserve age data, O'Neill looked elsewhere. His team analyzed the decay patterns of samarium, a metal that oxidizes upon exposure to air. Though the samarium itself had long vanished from the rocks, its isotopes left behind traces of their transformation into neodymium isotopes. By carefully dating two distinct neodymium isotopes derived from samarium, the researchers confirmed the rock's staggering age, 4.16 billion years. This alignment between multiple radiogenic systems provides compelling proof that we are looking at genuine Hadean material, O'Neill explained in a study published in Science. If true, this finding opens a unique window into Earth's earliest history, shedding light on processes that shaped the planet before life as we know it even existed. And this is the part most people miss. Discoveries like this don't just rewrite textbooks, they inspire new questions. Could there be other fragments of Earth's original crust waiting to be found? Some scientists speculate that similar relics might even reside on the Moon. Around 4.4 billion years ago, a cataclysmic collision tore a chunk of Earth away, forming our lunar companion. Future Artemis missions could uncover lunar rocks containing clues about Earth's infancy, bridging gaps in our understanding of planetary evolution. Still, debates rage on. Is the Nuvvuagittuq Greenstone Belt really as old as O'Neill claims? Or do alternative interpretations hold water? What if the methods used to date these rocks overlooked critical factors? These uncertainties invite further exploration and spirited discussion. So, what do you think? Do you believe we've finally uncovered Earth's firstborn crust, or does doubt linger in your mind? Share your thoughts below. We'd love to hear them. Discovering the oldest rocks on Earth.